Today we're going to focus on electric potentials and electric potentials energy. These are the answers for today's questions. Questions 1. The figure shows a charge of positive 2 microcoulomb and another charge of negative 2 microcoulomb fixed at points A and B, separated by a distance of 10 cm. Calculate A. The electric potential at the point B. B. The electric potential at the point Q. C. The work done to bring the charge of 5 microcoulomb from P to Q. How are we going to calculate electric potentials at a certain point? First of all, you need to know how many charges do you have in a system. So for these questions, we have 2 charges in the system, which is charge at point A and also a negative 2 microcoulomb charge at point B. Which means when we want to calculate the electric potential at point P, we need to calculate the electric potential coming from both of them. Let us begin with the equations. V equals to KQ over R. Now, if you look at this equation, Q is without modulus, which means when it comes to electric potential, you need to take into consideration the sign conventions of the charge. If it is a negative charge, then you need to substitute the value with the negative sign. So like we mentioned just now, since you have 2 charges in the system, therefore you're going to add up the potential from both of them. So Vp is equals to VAP plus VBP. VAP is the potential coming from point A. VBP is the potential due to point B. So let us expand the equations and substitute the values into the equations, and you will get Vp equals to 0. Now, if you notice, in these equations, I substitute the QB with the negative sign right now. Because like I mentioned just now, when it comes to electric potential, you must include the negative sign of the charge in your calculation. Let us repeat the same step for questions B, electric potential at point Q. V is equals to KQ over R, and since we have 2 charges in the system, therefore VQ is equals to VAQ plus VBQ. VAQ is due to the point A, VBQ is the potential due to point B. And again, let us expand the equations and substitute the values, and you will get VQ equals to 3.43 times 10 to the power of 5 volt. Question C determines the work done to bring the charge from Q to P. So by applying equations, delta V equals to WQP over Q naught. Now, WQP means that the work done to bring the charge from Q to P. So let us expand the equations. Delta V means V final minus V initial. So it is equals to WQP over Q naught. V final is our point P and V initial is our point Q. Therefore, these equations can be written as Vp minus Vq equals to WQP over Q naught. Rearrange the equations and substitute the values into the equations. You will then obtain WQP equals to negative 1.72 joule. Questions 2. 2-point charges of magnitude positive 2 microcoulomb and negative 4 microcoulomb are placed along a straight line as shown in figure. Questions 8. Calculate the electric potential energy of the system. B. If another charge of magnitude positive 6 microcoulomb is placed at the point A, determine the electric potential energy of all 3 charges. So when it comes to this question, both of them, they ask you to calculate electric potential energy. But one is for 2 charges, and the other one is the energy for 3 charges. To calculate the electric potential energy of 2 charges, we apply equations U equals to KQ1 Q2 over R12. So again, if you look at this equation, it is an equation without modulus, which means you need to take into consideration the sign convention of the charge in your calculations. So substitute the values into the equations and you will get U equals to negative 0.60 joule. So if you look at the substitution, now I substitute Q2 as a negative value. Next, let us calculate the electric potential energy for 3 charges in the system. Look at the diagram first. Initially, you are given a diagram with 2 charges and a point A. Next, you place a new charge, which is a positive 6 microcoulomb charge at point A. So this is the charges that you have right now. But if you look at the diagram, there's one missing info. The distance between positive 2 microcoulomb and positive 6 microcoulomb is not given. So we need to determine the distance between these 2 charges first. Before that, I would like to label the diagram as usual. So 1, 2, and 3. So now that I have everything ready, I'm going to calculate the distance. So R13 is equals to square root 12 times 10 to the power of negative 2 square plus 9 times 10 to the power of negative 2 square. So R13 is equals to 0.15 meter, which means the distance between positive 2 microcoulomb and positive 6 microcoulomb is equals to 0.15 meter. Now we have all of the information needed. Let us apply the equations for electric potential energy of 3 charges. So U equals to KQ1 Q2 over R12 plus KQ1 Q3 over R13 plus KQ2 Q3 over R23. So to make it easier, you can factorize the K out, and therefore the equations can be written as U equals to K bracket Q1 Q2 over R12 plus Q1 Q3 over R13 plus Q2 Q3 over R23. Next, substitute the values into the equations and you will obtain U equals to negative 2.28 joule. So that's all for today. I will see you all again tomorrow.